So in this question, you're given that Z1 and Z2 are two complex numbers such that mod Z1 is less than 1 and mod Z2 is greater than 1. And you're asked to prove that 1 minus Z1 Z2 bar by Z1 minus Z2 mod is always less than 1. So from this information, you're asked to prove that this inequation will always be valid. So how do we do this? So let us start our analysis. So if this has to be true, so let us try to go on and on taking this as valid. So now if this is true, then 1 minus Z1 Z2 bar mod by mod of Z1 minus Z2 should be less than 1. Because mod of Z1 by Z2 is mod Z1 by mod Z2. So if this is valid, then this has to be valid. Now mod of this is a positive number, mod of a complex number is positive, hence I can cross multiply this. If you have positive quantities, they can be cross multiplied. So this by implies, that means it works in both ways. Modulus of 1 minus Z1 Z2 bar is less than modulus of Z1 minus Z2. I am able to cross multiply this because I know that these two are positive quantities. Now, I'll square it on both sides. Because both are positive quantities and one is less than the other, then the square of this has to be less than square of this. This will not be valid if I am not sure that both are positive numbers. So this by implies modulus of 1 minus Z1 Z2 bar whole square is less than modulus of Z1 minus Z2 whole square. Now this by implies, we know that mod Z whole square is Z into Z bar. So mod of 1 minus Z1 Z2 bar can be written as 1 minus Z1 Z2 bar times the conjugate of this. The conjugate of this is 1 minus Z1 bar Z2 is less than, what is mod of this whole square? Z1 minus Z2 times Z1 bar minus Z2 bar. So this by implies, now let us expand the brackets. So 1 minus Z1 Z2 bar minus Z1 bar Z2 plus Z1 Z1 bar is mod Z1 square, Z2 Z2 bar is mod Z2 square. So mod Z1 square into mod Z2 square is less than Z1 Z1 bar is mod Z1 square again, Z1 Z2 bar minus Z2 Z1 bar plus Z2 Z2 bar is mod Z2 whole square. Now do you see some cancellations? Yes, these two are getting cancelled. So this by implies again, so if I send all of this onto, I'll send these onto this side. So 1 minus mod Z1 square minus mod Z2 square plus mod Z1 square mod Z2 square is less than 0. So this by implies again, so this can be nicely factorized, is nothing but 1 minus mod Z1 square times 1 minus mod Z2 square is less than 0. So if this has to happen, that follows this, so on. This follows this. And this is obviously true from the given condition. Because from the given condition, mod Z1 square is less than 1. This implies 1 minus mod Z1 square is greater than 0. Mod Z1 square is less than 1, hence 1 minus mod Z1 square is greater than 0. Similarly, mod Z2 square is greater than 1. This implies 1 minus mod Z2 square is less than 0. So this is greater than 0, this is less than 0. Now what is the product of these two? One number is negative, the other number is positive. That means the product is negative. which is what this inequation is saying. So this has to be negative, which is true from the given condition. Which is true from the given condition. Hence, this is true, hence proved. Thank you.